Hello, good afternoon to everybody. My name is Valsecchi, as a Sales Director of Belotti SpA. And Belotti is a manufacturing of a CNC machine for composite machining and also for light alloys, especially for the aerospace and automotive sector. And we are glad to introduce one innovation. So that is our Belotti ARC, so automatic riveting cell. That is something that we developed together with our partnership with the Dallara company. That is one of the main supplier of carbon fiber chassis. And right now, Mr. Engineer Davide Seletti will introduce the company, and then we go deeper in the solution that we propose, and then we have also exhibiting at our booth.
Thank you. Thank you, Loris. Hello. Thank you, Loris. Okay. Okay, thank you. So my name is Davide Seletti. I am the CEO of Dallara Compositi today. In my previous employment, I was head of composite for Formula One in Ferrari. So I mean, I am in the composite business since more than 25 years now. And a quick introduction about Dallara Compositi. Dallara Compositi is a company that belongs to Dallara Automobili, and we are in the range of, let's say, 30 million euros in sales last year, and we are over 200 employees, and the business is almost equally split, let's say 40% something between racing and automotive sector, and we have a nice good share about automotive and defense business that is growing in these years. Just to say that the main processes that we have is pre-preg manufacturing, and from the design point of view, we rely mainly on Dallara Automobili or build-to-print option in case we are working with other OEMs. What we are doing is, in Dallara Compositi, usually we start with process design and tooling design and everything that is needed to manufacture the components. We have one main production process that is hand layup and autoclave cure or compression molding cure. This is the process that we are using on the most of our products, and I feel that is the one that delivers the most in terms of performance to weight ratio for any composite material. It bears some cost indeed, and this is why we are working together with Belotti to think about technology that might reduce the effort in terms of man hours to produce components. And the next stages after cure, I mean, is obviously the machining, where I will talk about it in a later stage, and then we are going to final assembly, bonding operation, and then quality inspection and deliver to customers. When we think about what Dallara Compositi is doing, we are talking about some very different products. So because the range of our products varies, I have included aerospace and defense products, but just talking about racing and automotive, we cover a huge spectrum of products that go from high-end single-seater formulas, that means Formula One, and we do provide lots of components for us, including the chassis, but also front wing and also rear wing and crash boxes. So we are talking about, I feel, one of the most demanding structures that you can, let's say, produce in composite with very low safety factor and above all very low time to market. So that's a challenge every year. Then we have other single seaters. We are talking about Formula 2 and Super Formula that are in the picture. Then we have others, but I mean, I just wanted to show you what are, let's say, the most interesting products in terms of variety. Talking about sports car, those are two pictures of the same, let's say, spine that is a Dallara LMDH. The left hand is running with the BMW livery, and the other one is the Cadillac instead. On the bottom part, you can see instead the only Dallara cars that we sell to customers. In the right-hand side picture, you see the three versions of the Dallara Stradale, let's say, road legal car. Instead, on the left one, you can see what is called Dallara EXP, that is a track only. Let's say it's more power, but not possible to use on public roads. On the top right is the only automotive chassis that we do for an OEM that we can publish. There are far more, but unfortunately I cannot put in this slide, and it's the Bugatti Chiron. If you want to see the manufacturing process of that, it's pretty easy because, I mean, you go to YouTube, there is the National Geographic video that shows the whole of the manufacturing process. Well, not the whole of it, but I mean the most relevant part of it. How we do machine, let's say, parts, we have decided to have an approach that we choose the right machine for the right operation. So we do not have one single machine that does everything, but we choose the approach to have one machine that does the right stage. So we have, let's say, the picture in the middle is a Belotti FLA that covers, let's say, light machining of parts, so trimming and other operation, but also drilling, but not on a very precise components. Instead, we have for that small components, the Belotti FLU, and the Belotti MDL. You can see a picture of the Dallara Stradale chassis that you can see later in Belotti stand as well. With this approach, we try to have, let's say, effective operation both in terms of cost per hour, because I mean, if you use very large machine and very precise for, let's say, less meaningful operation, you bear the cost. You might still have the precision, but I don't know whether it's the right approach to have the right customer value. If we think about chassis machining, that is one of the aspects that we want to cover in this presentation. The big challenge that we have in Dallara Compositi is not the total numbers. I mean, there are companies that are maybe even far larger than us that cover large production of composite chassis maybe, but you will hardly find anybody else, I guess, worldwide that covers such a big range of products. Because we vary from single-seaters, 4 types in one single season, but the 4 types vary with very different numbers, from the very small number of Formula 1 chassis, because there are just a few that are needed for a whole season. Then the next season the chassis is going to be different, to other chassis that might last a few years, so the same chassis can race for years, but in the end we are not talking about relevant numbers. But the challenge is that we need to machine with the same milling machine 4 single-seaters, 4 types of single-seaters in the same moment. At the same time, Dallara Compositi is manufacturing also sports car that ranges year by year 20 to 40 per year of 2 types. One is the one that I've shown you before, that is the LMDH. And then road cars, we have even here 4 types that are Dallara Stradale and Chiron, plus other 2 I cannot show, sorry. And, but those, I mean, are meaningful number because a chassis machining it takes a lot of time. So in terms of working hours of a CNC machine takes time. But the challenge is to cover such a wide spectrum of projects are, well, precision indeed, process repeatability, especially for, let's say, road legal cars, but also LMH or LMDH cars are very important because, I mean, we're talking about numbers. So you need a process that you can repeat. Formula 1 has got, let's say, different needs, both in terms of precision and challenges. The other big issue is that you want to reduce to the minimum the operation that you do by hand. So really you don't want to use tool to machine chassis because in the end you don't have repeatability and precision. So to have the right machine with the right accessibility, maybe with 90-degree heads to go within the chassis, and to cover all the aspect of machining of where the designer want to have fixing point is very, very important. The next challenge, that is the link between this presentation and Dallara Compositi and Belotti, is what happened after the machining. I mean, quality control is another stage for sure, but for sure, before the chassis goes to the final assembly, you need 2 operations. One is a special operation, that is the bonding, so you need to bond anything that the designer wants to bond on top of the chassis, whatever is, either cover or structural parts. For the Dallara Stradale, you might have the roll-up covers to increase safety in terms of a rollover of a car. That is a composite structure bonded onto the chassis. But you have tens and tens of fixing points that are usually made by rivet nuts or Time-Sert or whatever, of many types, depending on the customer needs. That might be M5, M4, M8, whatever. And then all of those are fixed by hand. So you need operators that need to pick up fasteners or rivet nuts. And position by position, it's a very long operation that covers and needs many, many hours. and then each of them has to be checked for torque to see that everything was done properly. So the challenge in terms of reducing the cost, reducing the time, reducing the lead time of components is to try to do by robots whatever we can and reduce the need of manual operation. So I hand over the presentation to Loris for his part of Belotti.
Thank you, Davide. So, why we were thinking about this kind of innovation for this sector, for the automotive sector, is because we want to automate this riveting operation, this riveting process. So actually we are moving from the manual handling, so manual handling to riveting, all this kind of, and if you can see that there are 600, 700 rivets inside the carbon fiber chassis with a fully automatic process. So it means that this is the first innovation that we want to have the maximum flexibility for reaching all the space inside the chassis, and also with a completely fully electronic device. So it means that we will have like a closed loop where we can control all the main features during the riveting system. So it means that our system can even during the process, but also to have a feedback, immediate feedback for every single rivet during the process. So, Belotti ARC, that is made automatic riveting cell. So, we will handle all these kind of rivets or Time-Sert. And the main topics is that we can divide the process between pulling and screwing. So pulling, when we control even the force of pulling such a kind of rivets, or screwing when we are talking about Time-Sert application. So in this case, we are handling a different kind of diameters. So, and the flexibility during the process is with the same head, we can have multiple rivets with the different diameters, M4, M5, and 6, and also with a very easy changing of the tool for handling the rivets. In this case, we can see how is the collaboration is coming from. So it means we have the company Cosberg, where we have done a partnership 3 years ago, and they developed a patented head that is the core of this completed cell. So Cosberg is doing a tailor-made solution for, especially for small parts in automation. So, and this has an experience in the manufacturing more or less similar as Belotti. So they have also more than 40 years experience doing more in the automation sector. And of course, in this kind of solution, we can propose between aerospace or automotive. So we have an example as Dallara in completely automotive sector, but also in the aerospace where the amount of rivets is really huge. How it's made? So we have the complete cell that we are handling with the Comau robot, and then in this case we prefer to use Comau so we can use even Siemens drive and control the machine or the anthropomorphic robot as a CNC machines. So it's coming from our experience of the CNC machines that we can use also all the device coming from Siemens in order to increase the accuracy of the robot. So we have a payload of 170 kilo with the arm of 3 meters that is useful for reaching all the parts of the chassis, of the complete chassis. It's a compact and patented head, so due to the dimension we can reach every part of the chassis, also internal chassis. And we could have the position, so we can have a modular structure with different kind of solution that it could be a rotary table. What we are showing right now at our booth is one single station with a rotary table. So in order also to relocate the chassis during all the phases of riveting phases. So that will allow to do not have any repositioning of the chassis, of the component, during the process. So it means that we will not have any issue of repositioning with the error of the reposition of the chassis. And the innovative thing is that the collaboration due with Siemens and Comau and Belotti, we came to realize and offer on the market a solution that is completely handled by a CNC. So from an operator point of view, it's like a CNC machines. So we can program the CN as a standard gantry machine, and then we can use all the topics that are really dedicated for CNC. So like pitch error compensation, all this kind of compensation, thermal compensation. So all the devices that Siemens is offering for the machine, for the CNCs, is also used in this kind of application. And there is also an automatic feed-in system for loading all the rivets, all the kind of rivets. The process, now we will go deeper in the process, and also in the configuration of the head. So the head, this is coming from our partnership, as I said, with the Cosberg. In this case, we have a very compact and flexible head that could reach inside the chassis. But the main innovation is that we are doing everything electronically. This is a very important key point because on the market we have many riveting cell or riveting devices that are doing mostly pneumatic. The game changer is that doing that electronically, we can control completely all the feature. So it means that we have the force, the position, and the torque. So as soon as I control the force and the position, so it means that we have inside the head a positioning on the drill, the pre-drill on the chassis, as example, that we can compensate plus minus half millimeter because we can have, we will not be sure that the chassis has completely copy-paste as a 3D model, so we are not sure, so we should compensate even the location of the drill, and as soon as we are on the drill position, the head can automatically adjust the axial movement on the during the riveting side. So it means that I will position the riveting completely on the nominal value, so perpendicular to the hole. So checking the length, so I will know every time how much is the position, even axial position of the rivet inside the chassis, because it's completely controlled by an encoder. Then we know the force of pulling every single rivet, so we know, and it's controlled by the process, the kind of force, because sometimes in composite, you know, we cannot have always the same thickness, so it could be variable between all the chassis, so we have different kind of forces that we can apply, and the torque. The torque is really important to have a feedback. So as soon as I complete all the process on the chassis, I can control and see like a checklist which kind of rivet and which kind of torque I have from every single rivet. And sometimes could happen that maybe that you have a thickness of the chassis of the part that is too high, and then the rivet is not completely tightened. So it's really important from the customer point of view to have this report and this feedback as a closed loop. Automatic also relocating of the nose piece. So it means that as soon as we can change the kind of rivet and dimension, we can also change the tool that is managed by an automatic process. So, and the innovation from Belotti in partnership with Cosberg is that we can use only one head, so one head that we can handle different and multiple versions of rivet. The floating device is also very important because as soon as I'm positioned with the robot, so there is a movement, an axial movement that is due the head, is coming from the head, and the floating device will compensate all the flexion or deflection on the chassis. So we invite you at our booth, so G61 in this hall. So there you can see also the robot that is on a live demonstration. And also here we have a short video so we can demonstrate how is the process. So right now we have the first tool change, and you see this, the kind of rivets that we are offering in this solution. So the machine will take the rivet, will position inside the location point, And after that, there is an axial movement of the head that will install the rivet or the Time-Sert inside the, in this case, is a demonstration, so we realize some small parts to show also here in the exhibition, and release with always a feedback. So we created a proper interface where you can see that if the process has been terminated, so everything is, has been done in the right way, or maybe that could be any, let's say, mistake during the riveting. So all the key benefit of this solution, so of course one head with multiple inserts, that is something that we have as innovation. So with one head, multiple rivets, where we can manage different diameters. Then we have maximum flexibility. Of course, due to the robot anthropomorphic robot and also the rotary table, we can reach and have a flexibility to install almost all the rivets, or 70–90% of the rivets. So it depends a lot how the surface or the end point will be reachable. We have easy and very easy programming, because from the operator point of view, as a CNC manufacturer, and also from the operator coming from the CNC world, so there will always, it will be very easy to program and to move like a CNC and an ISO programming. Quality, so we can compensate, so for every kind of rivet, we can handle this kind of adjustment during the phase. So I mean, the floating head can be very accurate in order to follow the axial direction for every single hole. So it will for sure satisfy in terms of accuracy and repositioning, because we control all the cycle with a real feedback direct coming from the torque, how the rivet has been installed. And also, of course, for the productivity, that we are moving this kind of manual handling job right now to a complete automated process. So we will wait at our booth. So here you can see the G61 in order to show you and to provide also any additional questions. So we have a couple of minutes for some questions if you have, and otherwise we can meet, of course, in our booth. So if you have any question, please, we have 2 minutes again. Okay. So thank you very much for your attention, and yeah, if you have the possibility to join us again, G61, sorry, and then we can show you also live demonstration. Thank you.
Thank you.